And my title today is a little bit controversial in education because we actually cherish success and fear failure in education for good reason. But what I want to try to do is to convince you that there actually is a good reason that failure is part of the learning to success. And in order to start, I would like, this is a picture from the internet, I couldn't find anything better, but for a moment before I go, think about what has been your greatest failure in life and what did you learn from it. And you don't need to publicize this, you can keep it to yourself, but we'll come back to it at the end of the talk. So, I think you all had a moment to reflect. I'm sure everybody has an occasion. And so what I want to do today is first talk about our perceptions of failure and also how they're very culturally bound when we think about failure, in particular in the context of education. And then I will move to the second part of the talk where we talk about what I call failure by design, where we think about actually engineering failure situations as part of learning, and I will tell a little bit more about the recent research project in which that took place. And finally, I want to conclude on how we can kind of rethink failure for education and some takeaways for you to take back into your classrooms or into your research or into your own teaching. And I want to start clearly by recognizing the perceptions of failure in different disciplines are actually quite distinct. Failure is celebrated in business. If we are to look at a whole host of publications, you shouldn't do this now, but if you Google that failure in business, you'll find hundreds of book titles. This is just a small selection of what has been published. So obviously, business leaders, I suppose many of them have become successful later, so it is okay to talk about your failure and publish a book, but it's astonishing, I mean, how much it is part of discussions in business and not in education. I also came across by chance a fail festival which somebody had started, many cities and countries around the world, where people actually not just were writing books, but publicly discussing the failures of their business and what they learned from it. And one has a nice title, Shit Happens. I mean, you're an adult audience, so that's okay. And I think, again, that also speaks, I mean, to the sentiment in the business community, but particular in Silicon Valley, that people start and fail in startups, and it's part, actually, of, I mean, their curriculum vitae, if you want, to have that. So the Fail Festival was something which started a few years ago and went across the country. I don't know whether it was still going on, but it was an interesting find. But this is not the only area where people actually investigate failure. Not too far away from you, in Sweden, actually in 2017, the Museum of Failure opened. And it became also a traveling exhibit going to London and displayed hundreds of products, of failed products and services, and highlighted the important role of failure in innovation by showcasing essentially what didn't work. And then we also have in science and engineering, so business, design, science and engineering, a lot of evidence. The Duke professor Henry Petrosky is probably one of the most well-known figures. Oh. Okay, good. Who wrote about how people engineer bridges, and actually engineers learn from the failure of bridges. There is a whole history in engineering education. And more recently, Mario Livio wrote a book about brilliant blunders and how those blunders actually turned into new insights for sight. So I hope, I kind of made the case that in different communities, we have different discussions and acceptances of failure, which is not the case when we look at education. In education, most of the time, nearly all the time, when you type in the word failure in education and school, these are the kind of titles you get. They're very distinct from the ones you saw in the business world or in other contexts. And it's very clear in education we strive for every student to be successful. This is actually our task in compulsory public education, to help all students to become responsible citizens who can kind of contribute and work. But failure has this kind of touch of negativity. And we also know a lot of students who come from disadvantaged backgrounds. Failure for them is a daily experience, and obviously this is not something we should take lightly when we say about failure. But I also found a few instances where in education people have taken a different approach to failure. One of the interesting finds was a Kickstarter campaign. You can look this up for yourself, and the toy you can actually buy, somebody trying to design a failure toy. And she actually, in a Medium post, I believe, wrote about her 3-year journey, how hard it was to design a failure toy, because whenever we design toys, we really think about more successful play rather than make failure a part of the play experience. And I would be amiss if I didn't mention the seminal work of Manu Kapoor, who is now at the ETH Zurich, who has coined the term productive failure. And what she did was very interesting. In typical math and science classrooms, before students were given the canonical tasks of solving a problem, they were actually given, failure problems, where they were just exploring the problem space. They were not expected to solve it. And it turned out those students who had those failure experiences in the end turned out to be significantly more successful in solving problems later down the line. So in this case, he or the teachers were the designers of the failure problems for students before they turned to the regular classroom activities. And there's just recently also published a large research review which showed across a wide range of studies the success of this particular instructional approach. My particular context, as Nina already pointed out, is computer science education, which, as many of you probably know, in the last 5 to 10 years has gained incredible, traction now everywhere, not just in Europe, in the United States, but all over the globe. There is a concerted effort to bring computer science back into K-12 education. My former advisor, Seymour Papert, in the 1980 book, when we already had a first wave of computer science and programming in K-12, many have forgotten about that, wrote a really poignant line. He said, when you program a computer, you almost never get it right the first time. So this is very interesting. Here we have, a discipline where actually the norm is that when you design programs or whatever you do, you're not expected even to get it right. Failure is part of your expectation. But I think this particular fact puts a lot of challenges into classrooms when you have a teacher, 30, 40 students, and they're all failing in their programs. What's kind of to happen there? And all the problems they have, all the failures might not be the same. So how can we help students as well as teachers to become more successful in dealing with this indigenous problem of kind of experiencing failure in learning to programming, learning about computer science? The particular context I will talk about is not Scratch. I have done, lots of studies in Scratch, but something which I have been working on in the last 10 years, and it's called stitching the loop. And it's about actually designing electronic textiles. And electronic textiles, you see some examples here, are actually clothing like the one you're wearing right now. And then you use conductive thread to stitch, to sew circuits and connect them to a microcontroller. And these circuits then can be controlled to turn on or off or read in or output data via sensors and actuators. It's essentially the same as robotics, except it happens to be using textiles and thread rather than wires. And we was exploring computer science, which is a one-year-long introductory curriculum for early high school students, so students who are around 14, 15 years old. And they get a whole range of Scratch, web design, robotics. And so this is one of the concluding units. And we just checked this. I will show you a video because I think I can talk a lot about electronic textiles. It's more important to see what the artifacts actually look like that students create in a classroom. So let's go there. And now comes the moment we're all afraid, yes, that the video doesn't work, but it does.
Programming, I've never done anything with computers in general.
Because I thought it was going to be like all about computers and stuff,
Yeah.
but it's not.
I thought it was going to be a little bit harder to do.
At first, I thought you had to be really smart to code.
The eTextiles unit covers a series of different projects. Each one builds on the next. Students start out by making simple circuits and then eventually making parallel circuits with switches and computational circuits that they can program in customized ways. The programming includes a lot of challenging concepts, basic sequences, embedded conditionals, Boolean statements, mathematical operators, using sensors, and thinking through the logic of how to program those sensors.
It's not just crafting, it's sewing combined with circuitry. I love what you might call the hybrid nature of eTextiles.
To see the possible connections between crafting, computing, and engineering.
Our eTextiles unit seeks to bring making into computer science classrooms. We want to broaden who is participating in making in computer science. We want to deepen their learning by providing meaningful challenges to students. And we want to diversify who is making and what they are making. We're doing this by focusing on student-driven handcrafts.
The electronic crafting projects are not so much about teaching students stitching. Involves a lot of problem solving and thinking about procedures and steps, which I think connect very closely to thinking about computing and procedures.
But it's that transformation from their original ideas to what works and learning the skills, both programming skills and circuitry and crafting and all of those ways that those interweave.
It's usable. You can take it home with you.
Kids come in at lunch that I've never seen ever outside of the classroom without me asking them to. They just come because they want to do extra work or they want to make sure their project works.
I like to do challenging things.
So I think this gives you an idea on what this looks like. Oops, no, not again. What this kind of looks like in a classroom. ECS, Exploring Computer Science, is unique. It's the largest computer science teacher network in the United States with over 4,000 high school teachers. And nearly all of them work in disadvantaged schools, meaning schools where nearly all of the students never had any programming experience before and access to these researchers. But you can imagine seeing these projects that mistakes can happen on multiple fronts. We actually did an analysis of the debugging challenges which students faced by looking at their projects. And there are challenges in terms of crafting, I mean, in stitching the circuits. There are challenges in terms of writing the code and basic coding and doing the sensors. So as Seymour Papert said early on, and most computer science professionals know, making mistakes, making bugs is just part of the process. You're not expected, you can't get it right the first time. So this poses quite some challenges for students. You can see here because they also have to design circuits. And these circuits, by the way, are put into three-dimensional projects. I mean, the clothing, the toys, everything they designed is not just on a flat surface like a screen, but has a back and forth and sometimes a third dimension. And you see some example of the code which students need to write to kind of activate certain LEDs or sensors to read in data. So remember, these are all programming novices who have very little experience in circuit design, not necessarily in crafting and also in programming. But what I wanted to suggest is, obviously we could help students explain the bugs and everything. We turned the table, and as part of the curriculum, we asked the students actually to become designers of failure artifacts rather than to fix failures, which is usually the approach to debugging. We are asking students to make e-textiles which are buggy and giving them to other students to fix. So here the students are literally in the driver's seat rather than the passengers, and thinking about bugs in a very different perspective. We call this debugging by design, where students, first of all, create a hall of failure. You can call it anything you want. And so in the middle of the curriculum, we ask students to list all the bugs they have experienced. And this is something actually really important to make transparent how many different failure moments or bugs there are. Each student has probably only encountered one or two, but by seeing explicitly all the other bugs which students, other classmates in their class have experienced, it actually expands their idea of what can go wrong. And many things can go wrong. So we do this very simply with posters. I mean, you can also do this online. We actually have an online version of the curriculum. They look at the bugs, they classify them. So I think this is a very explicit discussion about the failure. And this is important for the next talk, because now students are put into charge of designing a buggy e-textiles which their classmates can solve within 1 hour. So what does it actually mean to create a Debuggit? I mean, which has different types of bugs, and these are here actually examples of students designing and testing it, and then preparing it with an intention statement to give to their classmates to solve. Here's an example. It was called the barfing rainbow cloud. I have no idea why. And it shows you the code. And there are some very simple, typical typos, like the variable names are mixed up. That happens very frequently to beginners. But then there is something really intentionally deceptive code, because those numbers actually don't really exist. And so this is very confusing. But it's also a challenge for beginners to create smart bugs. Because if you just delete a few lines of code, that's very easy. You don't need to think about it. But changing variable names or adding extra things poses a challenge for the other students to solve. And we asked students on how they thought. We were particularly interested when we talk about getting more comfortable with failure. There is an interesting concept by Stanford psychologist Carol Dweck, which talks about growth and fixed mindset. I don't know whether you've heard about it. And the idea of a fixed mindset is that you think, oh, I can't really do this. Whereas a growth mindset is the idea, I can approach this challenge, I know I will persevere. And Carol Dweck's argument is that this is a very important motivational stance that students bring to learning situations. If you approach programming, which by the way, or computer science, many students think, oh, this is not for me. I'm really not somebody who will be good at computer science. It will be very challenging for you to deal with bugs, because which they will invariably happen, and then you have to figure out on how to solve them. But if you have a growth mindset, then you're willing to kind of persevere through those struggles in addressing this. So you can see, I mean, there is a whole host of research, and typically in growth mindset, how people in programming, computer science have kind of taught this is saying is believing. So before you start an activity, you say, you believe you can solve everything. I think this is a little bit funny, but it's been done. Or people are shown different kind of strategies. So we were particularly interested in debugging by design, not only that students could kind of develop these bugs and fix them, but they also became more confident in solving them. So you have checklists, problem sets. Those are kind of some, the saying is believing exercises, testimonials. You have experts who come and say how they struggled. All of this is good, but it kind of tells the students just what to do. It doesn't actually put them in the position of agency of developing their own bugs. And so our idea was that by debugging by design, we could help students actually develop a growth mindset about bugs, and thus prepare them better for working with things. And this is a pilot study we did with 2 different classes who used this in the middle of the 4-project e-textile curriculum, which you saw in the video. And what you see here are different ways extracted from interviews as well as from students' portfolios, and how they kind of changed their perception of how they could solve. I mean, thinking about learning as a constant improvement rather than getting it right away. Students also were very effective in kind of giving praise to each other. Many of the classrooms are predominantly Latinos, so we have a lot of Spanish as well. And they also, in designing the challenges, chose more difficult problems rather than kind of to do it easy. And they were also able to persist after setbacks. And these are actually good kind of strategies for debugging. And most importantly, they developed comfort with failure. So the idea that you don't get it right the first time is very important. So I think what this kind of tells us, when we think about, want to rethink failure for learning, we can't just expect that students on their own become comfortable with failure. If you look at the outcomes, and we just actually completed this summer in July a quasi-experimental study with 400 students, about 150 of them in a comparable situation, in a controlled situation, and the others are in a debugging by design situation. We had a survey based on the growth mindset pre and post, and here are some of the findings where significant findings between pre and post surveys, that students felt more comfortable, more confident, and they also felt more comfortable asking for help, which is equally important. Sometimes you get stuck, you can't get unstuck, you have to ask for help, others knowing who to turn to. And we also saw that students actually developed a familiarity with a broader range of problems. This is what I highlighted when we said the hall of failures. Beginners have a very limited repertoire of experiences. They have maybe worked on a few projects, so they're not experts who have done or have seen hundreds of e-textile projects and everything which can go wrong. So I think an important step is to kind of give them an opportunity to see the range of bugs which are out there. And we also saw, because this project, Debugging by Design, was done before the final project, that in later projects, students actually avoided mistakes that they probably would have made hadn't they had that experience. And they also identified problems more easily. And some students actually took it on them to learn new code to make their debuggers. So it became an additional learning opportunity. One important teaching strategy, which we saw the teachers do in this classroom, was celebrating mistakes. So one teacher, for instance, would call out his favorite mistake of the day at each session. But equally important, the teachers would also showcase the mistakes they had made in their own e-textiles. So it was a little bit more level playing ground. It wasn't just the students making mistakes. The teachers were part of this community here. One of the teacher talks about his stitching. Most people are not familiar with crafting, so their stitches are very loose. And when the conductive thread touches each other from the positive and negative, it actually produces a short. No worries, nobody gets electrocuted there. These are very low voltage batteries, but that's an important part of this equation. It's not just about the students. The teachers also need to model this. And teachers observed that many students enjoyed making bugs for others. There was a certain mischievous quality of making it hard to mess with other people. Yes, that's true. That students in developing bugs actually had to think through what it meant, what could go wrong. And I think this is kind of something which is called in programming, computer science, developing notional machines and understanding on how the program actually works. And they made connections between different aspects which they actually had. I want to wrap up now. I have a partner team in Colorado who works on the technical side, also developing debugging tools, specifically for electronic textiles and beginners. A lot of the expert tools are not easily available in classrooms and handleable by beginners, so we're developing handheld probes, a software library, and circuit simulators, which potentially in later implementations will become part of the electronic textile classroom. After all, experts also have a whole toolset library at their disposal when they work on programs. Why shouldn't beginners have them as well? So there is a whole curriculum which you can download for free. We have created an online version because the study which I just mentioned took place during COVID, and our courageous teachers managed to implement this with 400 students. So we needed to redesign all the activities which you find in the curriculum so that students could actually do them on their own at home and with all the resources they had available. And we're just in the analysis, and one comforting finding is, while not all students finished their projects, we find that the students in particular from disadvantaged homes, those whose parents have no college degree, actually benefited the most from this particular intervention compared to the control group who didn't do the debugging by design activities. I want to give a shout out to the whole research team. You already saw Deborah Fields in the project, the graduate students, teachers, as well as our partners in Colorado Boulder who have been working with us for the last 3 years. So here are some key takeaways for you. I think when we think about bugs, we really think about it more from a passive stance. People have to deal with it. By putting the learners into the driver's seat, into control of making bugs, we can kind of change their perspective. We focused on growth mindset because that's a concept which is very much in discussion and seen as a positive aspect for students to develop. and could find evidence in the surveys as well as interviews that these activities actually expand, it strengthens their growth mindset. And that these, another aspect which is important when we talk about failure is motivation and emotion, and we saw that in the final reviews of the project as well. So for you to take home, you can think about, I asked you in the beginning to think about your own failures and lesson learned. Think about creating, celebrating mistakes rather than to ignore them or downplay them. They're just part of the learning process and will help students to develop a different stance. Organize a hall of failure or mistakes, however you call it, in your own projects. I'm sure you have ample examples of where things have gone wrong for teachers, students, or in your own design. Share mistakes of your own projects rather than just the successes on when work has been completed. And most importantly, put the students also in control of designing their mistakes for others as a way to become more comfortable as well as more knowledgeable about this. All right, and thank you for your attention.
Thank you so much, Yasmin, for a very highly interesting, very inspiring talk. I'm sure there will be a number of questions. I should say that the people hearing and watching the talk live can write in the chat, and then Maria will pose a question in here in the room. So I invite you all. Yes, Klaus? No, you're going to have to need to use the microphone,
so that the
because
people
otherwise
online
the people can't hear it.
Hear you.
So thanks for the talk. This is super interesting. I would say I'm a historian, so I come from a very different field. But I had some thoughts, and I don't know if they make sense, but I will try to ask them anyway. So one of them is about the group dynamic. So for instance, if you've been participating in research management courses and so on, there's a lot of talk about the different roles within a group. You need somebody who can close a project, someone who come up with the sparkling new ideas, and a lot of things in between. So, is that part of this problem solving? How does the group dynamic play into this? So, you talk about this kind of growth mindset versus other types of mindsets, but could it also be that the mixture of mindsets somehow would be beneficial? Or so I was just curious about your reflections on this. And then maybe kind of related to it, so the translation from computer science to other disciplines. So, for instance, as a historian having to teach history students, I see the point of some of it. The general idea about celebrating failure and so on, and not being afraid to talk about that. But a lot of the bugging, the exercise, it's just maybe my mindset, but it's quite difficult to see for me how to translate into, say, humanities as a discipline, or so I was just curious if you may have any thoughts on this.
Actually, to answer your last question first, I can even think in your particular discipline, interpretation of historical artifacts, because one of your business is to take primary sources and kind of situate and analyze them, and people don't always get it right. For people, what we publish in journals is usually the success story. Failure stories often don't get published. That's well known. So I can think in math, plenty of examples. Kids have hundreds of ways to get division problems wrong. So just to understand, not to keep it secret, but to make it part of a discussion that these mistakes happen, and what are the productive ways for. In science, we have a lot of examples that experiments don't go wrong. Go wrong or different interpretations. So I can actually see in design everywhere we have examples where mistakes or blunders and failures have occurred in interpretation, in creating artifacts, or in later uses, if you think about the Museum of Innovation, which I'm not saying that all what students should do now is just design failure artifacts, but I think about it as a pedagogical intervention we're very focused on getting students to finish projects. I mean, and to make that successful. And if you're getting that along the way, mistakes happen and failures, and these failures are not bad. They're actually an instrumental part of the learning process. And by making it intentional, you could just do the hall of failures, not students having design, just by making it more explicit, by revealing kind of what challenges you have run into and how you resolved them. I think there are multiple approaches which are not just germane to computer science, but can be easily extended into other disciplines. Now, to your first question about the group dynamics, students worked in teams actually of designing the failure artifact. So this was not an individual enterprise. The curriculum as well, you saw their beautiful murals created. These are always class collaborative projects because we wanted to emphasize collaboration for projects as well. It is clear in ECS there is a certain ethos. There are structures built in where students reflect, where students work individually and also collaboratively on project, and we have integrated all of these in the electronic textile unit. Remember, the students spend a whole year together. They meet at least once or twice per year. This is not a short-term project. The unit actually takes 6 to 7 weeks at least to complete. So as part of this, students have much less a challenge of working collaboratively on their projects or also collaborate on making mistakes. But again, that is something which doesn't fall from the sky. It's already kind of built into the curriculum on how the teachers throughout the whole year structure individual as well as collaborative activities.
Thank you, Yasmin. Further questions?
I think yes.
Yeah, Maria's got one from the chat, I think. You can borrow mine.
This is Christine Stable-Ben Diaz Thia, who is asking a very important message. Should a place like DS have a hall of failure? Is it possible to have a more generic type of that encompass multiple disciplines?
I didn't. You have to.
Yes. I'll try again. Christine is saying it's a very important message that you have. That's not a question. That's a comment,
a statement.
Right?
Yes.
A statement. Yeah. And then she's saying, like, should a place like DS here, with celebrating interdisciplinarity and the collaboration across fields, should we have a hall of failure? Is it possible to have a generic type that encompasses multiple disciplines and a generic type of failure hall, I assume is what she's asking.
Yeah, you can organize a failure festival of the DS Failure Festival. I mean, the precedents are there that people showcase projects which went wrong or into another direction or didn't work out as well. I think, I don't know enough about DS, but I think about academic communities, not just as communities which are very success focused. I mean, look at our predecessors here, but even somebody like Barbara McClintock, who wrote The Feeling for the Organism, had to struggle through decades of rejection of her ideas before it eventually became recognized. What she understood about the genetic structure of organism was actually correct, but at the time her methods, for instance, were not very much valued, recognized in the scientific community. So yes, I think it doesn't need to be, and it's also when you work with adults, it's a different situation, but even teachers could do that. I think teachers often also discuss their failures or mistakes in teaching as a way to share strategies they have developed to deal with complicated, complex classroom instructions. In Japan, there is a whole method around mathematics instruction where in local community, school communities, teachers actually regularly meet to fine-tune or to polish like stones their curricula by exchanging experiences and trying it out. So I think there is a lot of precedent for that already in other communities. We just haven't thought of bringing this to students. Because I noticed when I did a lot of maker activities, there was this push to get students to finish the project, to have success in their maker activity. And I think that's important, that's motivating, to see the LED lights turn on and flash and realize that you can make something happen. But I think in the process, we forget that the failures are as important and need to value them as much as kind of getting something finished. That's my point.
Thank you so much. Further questions? I would also like to, I have many questions, but
okay.
I can't take the whole floor. But I'd like to follow up on one of Klaus's questions about the growth of mindset versus the fixed mindset. And challenge, I mean, I know you were taking this as a perspective and it gave you interesting results, and I fully appreciate that. On the other hand, I do think this, for one thing, binary way of talking about mindsets is problematic. I also find it even more problematic that the question of how you approach a problem is an individual responsibility. And so it touches, at least, or it follows on from Klaus's questions about the collaborative nature of working together. From my more situated point of view, the question of whether you have a growth mindset or a fixed mindset is as much a question of the participation you have with your fellow students as it is a question of your own responsibility. And of course, you have a history of participating with your fellow students and teachers, so there will be dispositions to engage. But so this is turning more into a comment. My question is, do you see, would there be any, I really appreciate your way of looking at growth mindset practices, because that's a way of going about. It's not an individual responsibility, it's for us to design. Could we take that a step further so that we get rid of those associations of it being the child's own fault of having a mindset of being too fixed? Mm-hmm.
Short answer, agreed. I mean, end of discussion. No, I mean, we took it because the survey tool is there, and somehow I think it's also important to build connections to existing literature. But you're right, I mean, we have a whole study done on the mindset practices, and I think you saw in the examples which I showed to you that many of them actually providing help to each other, supporting, praise, I mean, are definitely much more collaborative, situated practices than just the learner itself. And those were instrumental in getting students to shift their perspective on where they are. So this is partially an artifact of, do we have the resources to develop alternative assessments which kind of capture this situated collaborative nature. This was not part of our project, but we tried through other venues, through interviews, as well as through observations to get at that.
Thanks. Marie, do you have further questions from the chat? I don't want to let anyone feel left out.
Not a question as much as an idea.
Yes.
Good, people have ideas. Good,
ideas are fine.
Let's share the hall of ideas, which
this is Christine Stapel-Bin, continuing with popping ideas. Great idea with the Failure Festival. Maybe we should also ask all guest lecturers to prepare to answer a question about a big failure.
Well, you might want to prime them up front that you expect that, so they can kind of carefully curate their failure experiences before sharing them with you. But we don't often hear this. We all have in our own research roads which kind of don't go any further, avenues which we have not pursued. And I think we talk conversationally with others about it, but it doesn't very often make it into the research paper. So people are actually not informed about those aspects of our own learning experiences in designing interventions or tools. They're often shared more as kind of colloquial lore among us, but they're actually an important part of that.
Further questions? I would then, I think we have time for at least one more question. I'd like you to ask, because I started introducing you as, amongst others, a Scratch developer and a Scratch researcher. And I would like to ask you about, now you're working very much with tangible materials. You know where this is going because you know where some of my interests are. Do you have any thoughts on how the tangible materials are different, or are they different than working in an on-screen environment? What does it mean that they actually, does it mean anything? Are there differences in terms of these being tangible materials that everybody can see and touch at the same time, rather than an on-screen environment which you can share on-screen with each other? What's the difference between a 2D and a 3D material?
I mean, there are advantages and disadvantages. So Scratch, has been a great success, not just as a programming tool, but also as a community. 10 millions, 100 millions of projects which are shared, and it's growing every day. We tried to replicate this with electronic textiles, thinking that we had Leah Beakley, who developed the LilyPad Arduino. She was at the MIT Media Lab. Scratch came from the MIT Media Lab. And it fell completely flat. There was you can Google this, the Lily Pond. That was our version of the Scratch online. And it was very interesting what so easily translated from Scratch on the screen and sharing didn't really work for the three-dimensional artifact. It wasn't as easy to share the photos, to record the artifact. We actually had to pretty much pressure our students to publish, the 100 or so projects which ended up in the Lily Pond. I felt really bad about it. In Scratch, it's a voluntary and very much cherished activity. People, just have discussion forums on how they can get their projects on the front page. Lots of effort is dedicated to this. So I think there are differences also in complexity, because here you're not just having computer science programming, you also deal with engineering. So you have to understand the basics of circuit design, which, by the way, are the foundations of electrical engineering of any computer. So, hey, there you go. But then the combination of kind of the handcrafts of making the circuits, and you have another dimension here, the aesthetics. These are not just functional circuits, some of them actually are part of the design. So I think it's inherently more complex, but I think those are real-world challenges. We have so many examples, even in this building, of automatic soap dispensers, of faucets which turn on and off, where the very same sensors and ideas which you find in electronics are embedded. So I think it's part of the larger repertoire of computational things on the screen, off the screen, in the world, we want people to explore. And then this is why I put this note on the bottom. The LilyPad Arduino is based on the Arduino, which is a very well-known open source hardware microcontroller. And it's really interesting when you Google that. You can do this right now. You Google Arduino, you get to see very different types of projects than when you Google LilyPad Arduino or Adafruit Playground. There's a whole host of them. We're actually not working with this anymore. Too expensive. We moved on to Adafruit. And I think, when we think about computational things, we also have to think about the technologies we use and how they frame who should actually design with them, and what kind of artifacts should be designed, because that signals to people, I can be a part of this community and make something, whereas maybe I'm not interested in robots, but I want to more design something soft, something wearable in this direction. The technology is exactly the same. So that is the shocking thing. But the usages, by customizing it, create a world of different applications, and I think that's important too.
Thank you so much, Yasmin. Please join me, everyone, in thanking Yasmin for a wonderful talk and very nice questions and answers.
I want to thank you for not asking the question on whether students are uncomfortable with failure. I invariably always get this, and I know that this is a challenge for student groups who have experienced a lot of failure. So I don't want to be glib about promoting this, and maybe we should come up with a better word, with a more positive word. So I realize, the particular association with it, but I think in particular for those students who have experienced a lot of failure in the school system, it's important to also feel more confident and comfortable about their own failures and finding solutions to them.
Thank you, Yasmin. That's an important comment. Even if we didn't ask you the question, we should have asked you that question. We have a small token for you to take home with you on the plane. It's a DS cup. We all have a cup here. It doesn't say Yasmin on it, so it doesn't have your name. But ours don't either. So you're exactly like us in terms of the cup, at least. Thank you so much.